Good morning. So like I'm recording now, like I said, we're starting with topic 28. And this is actually for any of you guys interested in chemistry or will be doing chemistry. Some of you might be doing it right now. But if anybody's interested in chemistry or the degree program, this is actually a pretty useful topic that you might see in another course. For the biology people or the chemistry people, this is definitely pretty useful. This is one of the applications of logarithms that you would use. So, this whole chapter, if you're wondering, what's the point of logarithms? What are we learning them for? This is kind of one of those examples. All right, so, okay. So, topic 28, applications of logarithms and then exponents. So let's look at this example. Now, the cool thing about this example is there's nothing new. So we're going to take all of the properties of logarithms we've been learning for the last week or 2 weeks and apply it to it's kind of like a word problem. You know what this is like? This is kind of like the question you guys had on your test where we applied a quadratic, meaning, we had like the height of an object and it was related to time. And we didn't learn anything new there. We just solved the equation using the quadratic formula and we found the height of the object or the time of the object. Same kind of thing here. We're going to take a logarithmic or exponential equation. You don't have to really know anything about it, about where the equation comes from, but we're going to apply mathematical information to solve it. So what I mean is, like this example here, you're not expected to come up with the formula, just like in the quadratic question on your test, for example. You didn't come up with the equation that showed like the height of a ball or height of an object, but you do need to know how to work with it. So let's read the question and I'll show you how it's kind of simple this question actually is. So the population of the world was estimated to have reached 6.5 billion in April 2006. Oh, this is an old question. The population growth rate for the world is about 1.4%. So the equation P as a function of time, which all that means is population is related to time. So P brackets T is equal to 6.5 times 1.014 to the power of the time. This represents the world population. So P is the population as a function of the number of years. So time is in years after 2006. Okay, so not too bad. The first question is actually quite easy. Oh, my calculator's over on the couch. I'll get it in 1 second. The first question is actually quite easy. It says, well, what's the world population in 2010? Okay, so this is an exponential equation, and P means population, and T means time. The only challenge with question A is, what is the time, right? Like how do we know the time? Well, time is in years. So the question is, how many years are we looking at? Well, the question gives you a bit of information here. It says at time equals 0, we're talking April 2016. So the question is, what's the population April 2010? Well, 2010 minus 2016 is 4 years. We are trying to estimate the population after 4 years. So, yes?
It's 2006. Where's your company?
Oh, what am I doing? Yeah, man, gee whiz, my brain. Well, that's funny. Thank you. 2006 to 2010. Obviously, that's where I get my 4 years. Sorry. My brain is like thinking of the question ahead, so I'm writing down different numbers than I'm actually trying to mean. So yeah, we start at 2006. You can see the years up above 2006, and we're going to 2010. Basically 4 years, right? If you were born April 2006, how old are you in April 2010? You're 4 years old. So all I do is I put 4 into my equation. Now you don't have to worry about this 4. This 4, just like see how it says P brackets T? This means population as a function of time. So don't solve this. Or don't use the 4. Just say P, right? P is equal to. Population after 4 years is equal to. And all you do is you put this number in on your calculator. 6.5 times 1.014. You raise that to the power of 4. Halas, the answer would be 6.87 billion. And I know it's billion because that's from the question up there, right? It says we have 6.5 billion. We're dealing with population in billion. I don't know if that's real, but it seems like a pretty realistic thing. I don't know the population of the world, but it seems like we're probably around 7 or more billion today. All right, question B, wink, 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 is one that you might need to know. So I've the other thing I can mention, and I probably shouldn't because I'm being recorded, but I have seen your final exam. So the good news for you guys is I can give you guys lots of hints between now and our review of certain questions. So when we do the review, or as I'm working through the end of this course, I can definitely tell you some good questions to practice. And something like B would be a good one. Yeah, B in both questions would be pretty good practice questions. So B is a really important one. So let's read the question. Estimate the amount of time. So guys, I'm reading question B. Estimate the amount of time for the world population to reach 13 billion. So like question number A, you could solve question number A before we even started this course probably. If you had a calculator and I gave you this formula, no problem. This might give you a problem if you never did this course, maybe. If you've never heard of a logarithm, it would be very hard to solve this question. But it's actually not that bad. So population is going to be 13 billion. Now, we only write 13, okay, because the number is given in billions. So we would just say 13 is equal to the rest of the formula. And all I want you guys to do is solve this. Well, we learned how to solve this last day. What we would do is, or what we can do, is simplify the equation as much as possible. We will still have an x or an unknown as an exponent. So remember our steps from Thursday. We're going to isolate the exponential expression. So we're going to simplify it, get as much as we can simplified, and keep the exponential on one side of the equation. But there's a problem. That exponential, let me just zoom in a little bit. Actually, that's too far. There we go. It's an exponent. How do we algebraically solve for that? Well, we need some way to bring that exponent down in the front. So we take the logarithm of both sides. It can be the natural logarithm or regular logarithm. It doesn't matter. You take the ln or log of both sides. Again, it does not matter. I'm a log person, to be honest. So, when we do this in chemistry, we typically just use log. It does not matter. The book here uses the natural logarithm, and the power property of logarithms says that because we're taking the logarithm of these numbers, I can move the t in front. And then I just solve for t. I'll do another one of these with you guys because, like I said, wink, wink, B is a very important question. So I'm going to solve for t. You obviously do this on your calculator. You can't do this in your head. So T will end up being around 50.
Mr. I want to ask you,
Yep.
the T will be different if I use log?
Nope. Try it yourself.
Okay.
If you're curious, just try in your calculator log 2 over log. Use your normal log button. It will be the same number. So it can't be the same. It shouldn't be the same. I say can't be. You can try it yourself. Make sure the book is okay with the answer. So this is where this question gets a bit interesting though, and this is where you guys might lose marks on a test or no, on a final. The answer is 50. So I'm asking you, well, two parts. What am I actually asking you? Well, you know what? No, this is a good answer. Here it just says estimate the amount of time. So the answer is 50 years. But if the question said, what year would it be? Well, it's 50 years from the beginning of when we started. So we started time equals 0 at 2006. So the year would be 2056. So if be careful with the wording, right? It's not an English exam or a communications exam, but just be a little careful. If the question says, how many years would it take to reach 13 billion? 50 years. If the question said, in what year will it be 13 billion, you would say it would be 13 billion in 2056. And again, if you're wondering where did I get 2006, that's where we're starting. When t is no time, it's 2006. When t equals 50, it's 2056. So you guys in 2056, check the population. We'll see if it's around 13 billion. That would be pretty scary, actually. That's a lot of people. That's too many people. But hopefully, inshallah, we'll all be around in 2056, and there might be 13 billion people. Scary. All right. Okay, let's look at this other example. I'm going to answer. I have a private message. I'm going to answer this publicly. I have a message from a student, and I hope you're listening. I won't say your name, but the private message is, can we talk at the end of class? The answer is yes and no, and that sounds really rude, I know. I have a test at 11:30 with another math group, so I can't spend too much time. But if anybody has questions about, like, say, your test or the course or the assignment, um, if I don't have time at the end of class, because I do have to get to campus and the tests are already ready. I just have to get to the campus and give them out. If I am in a little bit of a rush at the end of class, we can meet today or tonight or tomorrow. I'm free. Like, this is my only bad day where I have another test. But after today, I'm very much a free person. So to the student who asked, can we talk at the end of class? If I'm in a rush, we might have to chat a little later today, but you guys can send me an email anytime and say, hey, can we meet like tomorrow at 2 p.m.? And yes, I can. It's just today is a bit of a busy day for me, just because of that test at 11:30. Yeah, no problem. All right. And the other thing too is like the test at 11:30, there's a couple students who want to talk about that as well. So I'll be a little busy today, but after my test today, I am very, very free. So yeah, just for everybody in class, keep that in mind. I'm very free after 1:30 today. Okay, so let's look at this example. Now this is a chemistry example. Some of you guys, well, you might not have me, but you'll have some of my good friends in chemistry in the future if you're doing chemistry. And this is definitely a question you would see in a chemistry course. Well, kind of. In the chemistry course, you would have to come up with the equation yourself. But anyways, the half-life of a medicine is 8.04 days. What this means, and not that you need to know this, but if you're curious, this means after 8 days, let's just say 8, after 8 days, the amount of active ingredient in the medicine is reduced by half. It's called the half-life. You can kind of think of it like food going bad or something expiring. There's way more to it than this, of course, and you'll learn more in physics and chemistry. But half-life means after 8 days, this medicine has lost half of the ingredient, or it's been absorbed by the body about half. So this is not part of math, so don't worry. So the half-life of a medicine is 8 days, 8.04. If 10 grams of medicine is initially given to a patient, the amount of medicine present in the bloodstream after T days is approximated by this. So, in like physics or chemistry, you might have to come up with the equation yourself. In math, the equation is given to you. All you have to do is apply mathematics to solve it. Now, I'm going to give you one hint. If you see E, use ln. So if you were, now logarithm will always work. It's just ln will make your life a lot easier. So if you look up at this example up here, I told you you could use the natural logarithm or log because they're just numbers. But in this question, because there's an E, I highly recommend using ln. And we talked about this last day. I didn't upload the Thursday's class yet for the student who asked me, but this is in Thursday's class. We talked about when you see an E, use ln. Okay, question A, very simple question. How much of the medicine is still present in the bloodstream after 2 weeks? Now, very important. T is measured in days. Okay, T is measured in days. So for T, I'm going to use 14 because 14 days is 2 weeks. Don't worry, you won't have to do any crazy time conversions, on your final. It's the final exam. Actually, the final exam's pretty good, like pretty easy. And I know you're like rolling your eyes at me saying that because the test 1 and test 2 were pretty challenging, but I really think the final exam's pretty good, pretty straightforward. And you don't have to worry about crazy time conversions on that. So 2 weeks, 14 days. So all I'm going to do is solve for the amount of medicine. Again, don't worry about this 14. And what I mean is don't use this number. All I need to do is solve this on my calculator. And if you put this number in on your calculator, 10 times E to the power of negative 0.0862 times 14, your calculator will say about 3 grams. One thing I'll quickly show you for the people who weren't here or can't remember, if you can see my screen here, the letter E, if you're looking for it on your calculator, is here. And this is why we use ln. The reason we use ln for E is because it's the second function of that button. So all I'm saying is E and ln are related. They're naturally related, pardon the pun. Okay, back to the notes. Sorry. Okay. So, question B, let's read it. How long, so this is, again, B, wink, wink, big important question here. How long will it take the amount of medicine to be 0.5 grams? So what we do is we put in 0.5 for here. This is very much like the height question on your second test, where you would put the height here. A lot of people on the test didn't do that. On the test, you had like height as a function of time equals like something something squared plus something something x plus something. And it said what would be the time at 60? You would put the 60 here. Okay, that again, we can talk more about that later. I'm going to put the tests outside my office. But this is very similar to that question where I'm going to put the 0.5 in for A. Now I'm going to use my mathematical skills to solve for this. So I'm going to isolate the exponential expression, meaning I'm going to get rid of this 10 here. I'm going to divide both sides by 10, so I get rid of the 10s, and I'm left with this. Now, what I'm going to do to solve this one is I'm going to take the natural logarithm of both sides. Now, a little bit differently, when you take this is something, again, we did this on Thursday, so I'll have that uploaded for you today. When you take the natural logarithm of e, and you can do this, you can try this on your calculator if you want. If you put this on your calculator, and you can try it, well, sorry, I guess you can't put the t on your calculator, can you? But if you try ln e on your calculator, it's just 1. So what happened, and actually you don't even really need to know that. What we're going to do is we're going to move this exponential down front. So you guys might be wondering, okay, if we move it down front, what happened to ln e? Where did this go? Well, ln e is just equal to 1. But you don't actually even need to worry about that. You can still put all this in on your calculator. I'm going to show you this now in a few minutes anyways. We're going to do a practice problem. But yeah, the ln, so you move, let me just explain that again, because the book kind of does this a little, not complicated, but it might be easier if you just remembered one method. So you take the logarithm of any side, the number goes down here. So I'm still left with ln e. And the reason that this disappears is because ln e is equal to 1. So the question just gets rid of it. You can try that on your calculator. All right, so there you go. And then, of course, you solve it and you get your answer, 34.8 years. All right, let me do one or two for you, and then maybe I'll get you guys to practice. I'd like to do a ln one with you. Okay. I'll show you 2, and then I'll get you guys to do 1, and then we'll move into chapter 4, which is, again, don't worry. I know this is the last week of classes, but chapter 4, we're only doing a couple topics from that. All right, so let me do number 2 and number 3, and then I'll give you guys a couple minutes to try one of these. I might get you to do something like number 1. Yeah, I'll do 2 and 3. I'll get you guys to do 1. Okay, number 2. The population of Delhi, India can be modeled by the equation below. PT is the population in thousands, and T is years since 2001. So what that means is when T is 0, it's 2001. What was the population in the year 2010? Okay, so 2010. 2010 from 2001 is 9 years. So my population after 9 years, again, don't use the 9 for calculating, but this is kind of how we write it, is 9817 times 1.031 to the 9. Solve that and you're done. Now, hold on. My calculator is over here somewhere. All right, I got it. Sorry, my calculator was on the couch. I was doing some work last night. So 9817 times 1.031 to the power of 9. And you get 1, 2, 9, 2, 1. It says 0.3, but you can't really have 0.3 of a people, so I'll just say people. So the population in 2010, I don't think Delhi, India is that small. Oh, this is in thousands. Never mind. Sorry. So let me fix that. It's in thousands. So this will be 1,000 people. There we go. Nasser, you have your hand raised.
Yeah, good morning, Mr. Mark. T represents the period of time?
Yes.
Okay, thank you.
No problem. All right. Question B. Predict the population in 2019. Oh, this is, oh, I'm doing an easy one. This one's, oh, okay, C is the one I really wanted to do. There you go. So P says predicted population in 2019. So same thing, 2010, sorry, 2001, we're going to 2019. So that's 18 years, P18. So I'm just going quick through this because it's the same question again. I'm just using a different number of years. All right, we'll see what I get. Oh, I just cleared my calculator. Hold on. Yes, okay. I kept the same formula in my calculator. So it's 17007. Now I'm adding 1, 2, 3. I'm adding 1,000 because the number in population is given in thousands. So this is like a lot of people. This is just like a math problem. This obviously isn't like a real answer or anything. It's just a practice problem. Okay, question C. C is the big one. If the growth rate continues, in what year will the population meet 15 million people? Now, 15 million. Okay, if you were writing 15 million, the number 15 million would look like this. Now, we're measuring this in thousands, so we can get rid of the 30. 15 million is this many thousands. The word thousands replaces those zeros. I don't think the question on your final really gets you to worry about that. No, it doesn't. So on your final, the question is, you just use the actual number. You don't have to worry about this conversion. But yeah, 15 million is right here. So if I was going to change that to thousands, I would take the 3 zeros for 1,000, and it would be 1,500,000 people, which is a million. I know that sounds really confusing, but it's not something you really need to worry about converting that number. Okay, so let's put it into our problem, our formula. So our formula is PT equals 98171031 to the time. So I'm going to put in my number here, 15,000 thousands. So 15 million as thousands, 9817 1.031 T. Now, my goal is to get T by itself. So what I'm going to do first is divide each side by this number. I want to get the T, I want to isolate the T to get it all by itself. So let's do that on my calculator. So here I get 1.528 equals 1.031 to the power of T. Now what I want to do is take the logarithm of both sides. You can use whatever you want. You can use log or you can use ln. It might be easier to just keep using ln because all it is a number on your calculator. So take the logarithm of both sides. Okay, so I'm just going to pick ln because, you know, at least with ln, you'll never be wrong. So I'll just go ln 1.528 equals ln 1.031. Now what that lets me do is bring the T down front and I'm almost done. ln 1.528 equals T ln 1.031. Now solve for T. T would end up being ln 1.528 over ln 1.031. That's it. We're done. Put that in on your calculator. You're good to go. Okay. So I get 13.8. So you could say 14 years. Done. So what does it say? If the growth rate continues, in what year will the population reach this number? 14 years or 2015. All right, let me do one more. Oh, why are they giving me so many? Okay, I'll do 3 and then I'll get you guys to practice 1 and then we're going to move on to chapter 4. Excuse me. So the growth of a bacteria in a culture is given by the equation A of T, so like amount, is equal to 500 times E. You know, you can see the equation there. I'm not going to read it out. AT is the number of bacteria and T is the time in minutes. So what is the initial number of bacteria? Okay, well, the initial number of bacteria is when time equals 0. That's a good physics question for you. The initial time is basically, unless somebody says differently, 0. So I'm going to solve this equation by putting 0 up here. Okay, so AT equals 500 times E to the 0. You can do this on your calculator. Anything to the power of 0 is 1. So 500 is your answer. The initial number of the bacteria is 500. That's it. Okay, so A says, what's the population after 10 minutes? All right, well, the population after 10 minutes is 500. E 0.0277 times 10. And that's it. Put it in on your calculator, no problem. Just make sure you use your E button. It's above the natural logarithm. And I get 659 well, no, it says 659.5. So let's just say 660. Easy. Now it gets a little harder. If the growth rate continues, how long will it take the population to double to reach 1,000? Well, all right, let's see. So my population here is going to be 1,000 equals 500 E. I'm just putting it into the equation, except now I put a T there. I'm trying to find time. Okay, well, what I need to do is I first need to isolate this. So I'm going to divide both sides by 500. Okay, so you end up getting 2 equals E to the power of 0.0277t. I'm going to take the natural logarithm of both sides. Okay, so ln 2 equals ln E. Okay, now my exponent will come down front. I'm going to do this one a little slower for you, a little differently than the book shows you. So what you end up getting is ln 2 equals 0.0277t times ln E. Now, normally what we would do is then we would divide everything to isolate the t, meaning, you know, we could divide this side and the other side by my numbers. But anytime you see the natural logarithm of E, it just equals 1. So this becomes ln 2 equals 0.0277t, and just solve for that. So t will be ln 2 over 0.277. And that's it. So I put that in on my calculator, ln 2 divided by 0.0277, and I get my answer. T is 25 minutes. Awesome. That's a good one. That was a good question. I like that question because we didn't have to convert the time, we didn't have to convert the population, just a nice, easy question. So it's kind of similar on your final, easy time, easy number, something like this. All right. Well, I'll leave that up for 1 second. Just absorb it, write it down, make sure you know it. This is being recorded anyways. And then I'll get you guys to try one. And then I'm going to we'll get started with chapter 4, which is, again, we're going to kind of cut some stuff out of that. All right. In what year? In millions. Okay. Well, you guys can try number 1. All right, I'll leave the questions there. I'll give you guys a couple minutes to try that. Question number 1 about the population of China. I won't say anything because you guys know like what to do. Just try A, B, and C. Well, sorry, I will say one thing. The population is in millions. So this number is 1,237 million. So in C, when they ask you to figure out when it'll reach 2 billion, you're going to use this number. 2,000 million is 2 billion. All right, so I'll be back in 5 minutes. We'll check your answers.
Mr. Is it 51 billion?
I'm sorry, can you repeat what you said? I missed that.
T is in C, T equal 51, right?
All right, well, let's see. Let's do the answers. All right. So population in 2022. This is so it's 1998. Let me zoom in just a little bit. So this is 4 years. This one would be 11 or 21 years, would it be? 2019 minus 1998. 21 years. So let's see. My population, 1237 times 1.0095 times 4. I'm going to do the same thing for B. 1237 times 1.0095 times 21. And let's see what our answers are. So I'm just going to put this into my calculator. I'm not doing any crazy math here. Everything is normal, you know, no rearranging. So I end up getting, not a big increase in 4 years. Well, I mean, it is a lot of people, but in terms of the number, 128, let's say 5 million. Right? Remember, the number is in millions. So this would be 1,285 million or 1.2 billion. So a lot of people, 1.3 billion, I guess. You'll notice I rounded the year up. So there you go. 21 years. Let's try that. '21. So I get for this 1,509. So you could say 1,508. I don't care, but you know, you want to round up here. So 1,509 million people.
In the range, right?
Sorry?
In the range?
Yeah, about. Like in math, you would use squiggly brackets, or squiggly equals. It's about 1,509 million. This is, these models are real, by the way, as in, I don't know if these numbers are real, but this is what a biologist or sociologist, I don't know if that's the right word, anthropologist, I don't know. But this is what people would actually use to predict populations. I don't know if these equations are perfect, but this is like a real type of question. And it's always an approximation. You know, things like COVID or a drought or an earthquake or something can change the population very quickly. I have a private message here. Is it okay if I didn't round my answer? No, round your answer. You don't want to say like 1508, like my calculator says 1508.698604. Do not put that down. That's too many numbers. Round your answers. Okay. If this growth rate continues, in what year will the population reach 2,000 million people? 2 billion. So what I'm going to do here is I'm going to put 2,000 here. And this is equal to 1,237, 1.0095 times t. Now, first step, isolate the exponential. Isolate this guy on the left. So what I'm going to do is divide both sides by 1237. So just do that on my calculator here. And I end up getting 1.617 equals 1.0095 t. Okay, so I'm going to take the natural logarithm of both sides. You could take the logarithm of both sides. It doesn't matter. Okay, that brings your t out front. So I'll get ln 1.617. You guys don't have to write all of this down, by the way, if you're doing this on a final exam or something. I'm just showing you every step. So I finally solve for t. It will be ln 1.617 divided by ln. Oops, sorry. I'm going quick. No, I'm not trying to go quick, actually. I'm just trying to like get this question done because I want to see if you guys got the right answer. Obviously, this number here is 1.0095. I didn't mean to change that there. Okay, divide those out and you will get your answer. So let's see what we get. Okay, just give me a second to put it in on my calculator. And I get 50 or 50, well, I get 50.8. So 51 years. Woo, there we go. Not too bad, pretty easy. Well, you know, a lot easier than some of the other questions. All right, cool. So that's it, halas. You guys can practice some of the other questions. There's a couple more. And then there's answers. So you guys can, you know, your answers to Unit 3 are down here. So we're done. We finally finished Unit 3. Not too bad. Well, I mean, Unit 3 was probably the hardest unit, I think, out of all units. But it ended pretty well, pretty good. Okay, let me open up the next chapter. It's 10:30. So, and I do have a test at 11:30. So I won't go too much longer. I will introduce chapter 4 to you guys, but I just have to download it to my computer. So just give me 1 minute here. To open up your math. Give me 1 second. So I'm just opening up, I'll show you what I'm doing. I'm just opening up Unit 4 here, and I'm going to download it to my computer just so I can write on the screen a little bit better. Oops. Give me 1 second. Downloads. There we go. Computer being a bit slow today. All right. So like I said, we won't go too crazy with this because I gotta leave for a test. But this is the last unit. Now this unit is, I'll scroll up in a minute, but it's significantly shorter than the other units, like by a lot. It's only it's only 42 pages. We only have a couple of classes left, and the other people are in the same, other courses are in the same kind of place we are. So we're going to focus on some of the important parts of Unit 4. Unit 4, and again, this will only take us probably 2 or 3 classes, is, I don't know, I personally love it, but maybe it's not everybody's favorite type of math. It's kind of like an introduction to trigonometry. So if you can't remember from previous school, trigonometry is the math of like angles and triangles and shapes. And we're going to kind of keep it to triangular trig in this course. So solving for, or well, I should say right triangular trigonometry. Sorry, that's what I meant to say. So we're going to keep this to basically right triangles. That's a very important statement to make because right triangles are something you're going to use a lot in physics. One of the math instructors, another guy who teaches this, is mostly a physics instructor. And he says the right triangle trigonometry is really, really important. It has to do with kind of the initial velocity or like kind of like the initial speed of objects going off at a certain angle. So for anybody in physics or doing physics in the fall, this chapter will be very, very useful for you. I think the last chapter would be useful for anybody going into biology or chemistry. This is definitely the most useful for physics. And units 1 and 2 are just good for everybody because you'll need it in business math, in medical science, engineering, IT, whatever. So, whoops. Trigonometry, we're going to keep it basically to right angles. So we're mostly going to focus on this part here. Okay, I'll let you, like, you'll know before we finish what topics to study, but we're going to start here actually on page 6. Okay, so we're going to start on page 6. So right here is where you're going to start. Okay. So page 6, chapter 4, this is our starting point. Introduction to trigonometry. That's what section 2.2 is starting. Now, actually, one thing I'll mention, let me just erase this. Hold on. I'll write something back again in a second. But I do want to mention one thing before we get started. So you can start studying here. Oops, here. This is page 6 of chapter 4. One thing I will mention, though, before we get into this. What is a right triangle, right? A right triangle is a triangle, so a shape with 3 sides that has a 90-degree angle. And in math or physics, we represent a 90-degree angle, I zoomed in way too much, with this shape here, or with this like kind of shape here, this little square. This means 90 degrees. We're going to talk about degrees. We're going to talk about these triangles as we move forward. But if you're wondering what a right, you're going to hear me say this a lot, a right triangle. This is a triangle that has a 90-degree angle in the corner. Okay, and the other angles we'll figure out. We're going to talk more about this as this continues. But this is a right triangle. So let's start with the introduction to trigonometry with something. Well, I'm going to ask you guys, I know it's early, it's Sunday, you guys it's the end of semester, you're all tired. Have you guys heard of this? Has anybody in class heard of the Pythagorean theorem? I really hope so. Doesn't matter if you haven't, but has anybody? Yes, no?
No, no.
No? What did you guys?
Yes.
Yes, okay. You really should have learned this in high school, but again, it doesn't matter because I'm going to teach it to you. I got a lot of yeses in the chat as well. Okay, cool. If any of you have heard this in high school, this is straight from your high school. If you've never heard of this before, we're going to do, oh, and sorry, I'm Canadian. We say high school. For you, it might be secondary school or like grade 10, 11, 12, something like that. Maybe earlier. I think back where I used to work, maybe grade 8 or 10. I can't remember. It doesn't matter though. I'm going to teach you what this is. This is a very famous theorem. I think, you know, I don't know if I'll be a teacher for my whole life. And if you asked me when I was like 70 years old, so, you know, 35 years from now, I guess I'm getting pretty old now. If I could remember any formulas from chemistry or math, there's definitely a few in chemistry, but this is one of the math formulas I'll never forget. You know, something like the quadratic formula, I do kind of remember, but I don't think I would in 30, 40 years. I'll never forget this theorem. I don't think so. One of the most classic math equations, and you hear about Pythagorean a fair bit, famous ancient mathematician. He came up with this theorem where you could find the length of any side of a right triangle. It has to be a right triangle. And again, what I mean by, you can see this in italics, a right triangle must have an angle of 90 degrees. And I'll talk about what angles are and all that if you can't remember, but this angle here is a 90-degree angle. Okay, did anybody have a question? Because I heard a microphone. No, okay. So this formula you must know right here. Make sure you know this. Okay, very, very, very important. C squared equals A squared plus B squared. So what this formula means is the square root of C will equal the sum of the square root, C squared, I said square root, sorry. C squared will equal the sum of A squared and B squared. Now, some of you guys, you're looking at capital A, capital C. Those represent angles. So A, B, and C are angles, whereas little c, A, and B, so we would say lowercase, these are lengths. And we're going to look at this today, tomorrow, the next day. Like there's not a lot in this chapter, so you'll kind of get used to this concept of angles and lengths. Okay, so example number 1. Now you'll notice this chapter is a little different than the other chapters. It's not really been solved for you, so I'm going to have to do it. Example number 1. If triangle ABC has an angle, so it is a right angle. Angle A is 90. Oops. So this is a right triangle. C is 10, B is 6. Find the length of side A to 1 decimal place. Now, I could draw this angle if I wanted to. The way that this, and you do not need to draw this, but the way that this one would work. Oh, why are they doing this to you? Hold on. Okay, this one, okay. We do have to draw this one. This one's being a little mean to you. Okay, so I think this is going to confuse some people, but that's okay. Angle A here. Angle A is the 90-degree angle. So what that means is this is going to be side A. Okay, and then C and B don't really matter. C and B I can put here. It doesn't really matter which angle C is or which angle B is. This would be angle C. This would be angle B. Notice that the angle A is across from side A. Angle B is across from side B, and angle C is across from side C. So what this formula means, or the Pythagorean theorem says, that the angle of the long side, this is called the hypotenuse, the longest side. The angle of the longest side will equal the length, or the lengths of the other two sides added together. Now, this is where I'm assuming some of you are getting confused, because you're probably saying, whoa, 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 this is not the same as this. No, this is just a general formula. The formula means that the longest side, the side across from the right angle, so the longest side here, side C, is always equal to the other two sides squared. So A is my 90-degree angle. That means this is my longest side. So it's going to be my longest side, my hypotenuse. And then these are the other two sides. We call them legs or sides. All right, so again, if you're looking at this saying, whoa, 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 you are not using the same formula, it's because this isn't really a formula we're going to stick with, in the sense that these letters will change. This could be X, Y, and Z. This could be H, R, and B. It could be any letters. The formula is the longest side, the hypotenuse, is equal to each other side squared. So A squared is going to equal B squared, so 6 squared, plus C squared, 10 squared. Okay, so let's see what that is. That's 36 plus 100, so 136. Now, I'm not done. I need to solve this, and you guys should remember how to solve this from last unit. So the reason we spent all of that time doing the last unit, let me pick a different color here. Hold on, I'm just picking a different color so it looks a bit nicer. Give me 1 second. Tools, comment. Okay, sorry, I'm gonna go with, I don't know, what am I feeling here? Let's try blue. So when I solve this, it's going to be the square root of A squared equals the square root of 136. So A will be root 136. We're gonna do more of these, don't worry. So I end up getting 2 root 34, or you could put this as a decimal if you wanted, 11.7. Whatever one you want. I think we're going
Clear?
to, sorry, 1 second. I think we're going to use the decimals in this unit more than anything. Yes, you had a question?
We cannot replace A with 90 because A is 90 or no?
The angle is 90, not the length.
Okay.
Yeah, the angle. That's a very good question. The angle is 90 degrees. So really what you guys need to make sure you know is the difference between a length and an angle. The angle is like kind of like the space between the 2 points. Let me show you another one, and this will make sense. that was a very good question, actually. Oh, hold on, view, page display.
So, Mr. Mark, in this
Yes.
question, we found the length of A.
Yep.
A small.
Yes, we did.
Okay.
So let me show you another one. What color? Let's go purple. Okay, I have a triangle PQR. I'm just going to keep drawing my triangles the same. As in, I'm going to draw my right triangle like this. Okay, triangle P, and this is why I told you guys, like, the letters A, B, and C, don't memorize the letters. It's not about the letters. It's about the shape of the triangle. So triangle PQR. Angle P, so this angle is P, is 90 degrees. Okay, so that means little p, side P is across from it. And that's how it always works. Now the other angles, oh, and it tells me that P is 32. Sorry. I know it's really hard to tell the difference between big P and little p, but anyways, you'll see with the R. It also says that side R is 28.3. Now, the only side that's important that you get right is the right angle side. Remember, this is the longest side. We call it the hypotenuse. It's the longest side across from the 90-degree angle. That's the only important side. It doesn't matter what the other angles are. So I could call this Q and I could call this R. It doesn't matter where the R and the Q go. So that means little r would be on the bottom across from the big R. So little r would be 28.3. And little q, we don't actually know. It's asking us to find Q to 1 decimal place. Okay, well, now I'm going to set up my formula. Let me pick a different color for 1 second here. The numbers that I care about, and this was what the student just mentioned in the chat there, I don't care about the number 90. The number 90 is the angle, the space between the two legs, we'll call them. It's 90 degrees. If you don't really know what degrees mean, by the way, if you play video games, you probably know a lot more about degrees because, if you were starting at a point and you spun around, it would be 360 degrees. So this angle is open 90 degrees. It means it's a quarter of a turn, which we're not really dealing with turns here, don't worry. But I notice like any of my students who play video games usually know what 360 degrees means. It's a full turn. 90 degrees means a quarter turn. You can kind of think of it like a clock, right? An old clock. 90 degrees would be the difference between 12 and 3. 180 degrees would be the difference between 12 and 6. And then you could go on and on all the way back around to 360. We're going to talk more about this, not today, but tomorrow. But you can kind of think of it like a clock. The difference between 12 o'clock and 3 o'clock is 90 degrees. All right, anyways, we'll talk more about angles tomorrow because, guys, after this, we're going to start talking about angles. So if you kind of don't know what an angle is, don't worry. Again, like I mentioned, we'll talk about that tomorrow. Anyways, okay, so this question. Again, this formula up here is a general formula. Actually, you know what I could have put the square around is the top one. It's the hypotenuse squared equals each leg squared. So my hypotenuse is 32. Let me go back to purple here. So my hypotenuse is 32.0 squared equals, well, I mean, anything. It could be r squared, q squared. It doesn't matter how I put this, but I'll say the r leg 28.3 squared plus q squared. Now, I just want to solve for q. We know how to solve for q. We just did this in the last chapter. I'm going to take the square root of both sides. But let's simplify this first, right? Let's make our lives a lot easier. So what I'm going to do is I'm going to put the q here, and it's going to equal 32 squared minus 28.3 squared. That's just algebra. You know, I hope I don't have to review that. I moved the 28 over, and it became negative. And you guys know me, I like my variables on the left. So q squared equals 32 squared minus 28.3 squared. And that'll give me 223.11. So q squared equals 223.11. And I have one last step. I'm going to take the square root of both sides. I'll even do it like that. And you'll get your answer. Q is the square root of that answer. And I get 14.9. And there we go. That's it. Little tricky if you've heard of Pythagorean, like I noticed in the chat, a lot of people did. This is probably very easy. If you've never heard of Pythagorean, you might need to do a little practice here. So speaking of that, I'm going to ask you guys to practice this one, and then halas, that's it for today. I would like to do a little bit more, but I do have a test, so I need to kind of get ready, make sure that's all printed and good. So just do practice number 1, and then that'll be it for today. And we'll look at the answer in, I don't know, let's say 3-4 minutes. Okay, so I'll be back in 3 or 4 minutes with the answer. Good luck. Put your answers in the chat, by the way, if you want to. I drew a little shape there that might help you guys get started. The only reason I drew the shape is so that our answers are going to be the same no matter what. But, our letters will kind of mean the same thing. You can draw whatever shape as long as it's correct. It needs to have this information in it. but I just gave you a starting point with the triangle. All right, I'll stop talking. I'll be back in two minutes or so. And I want you to find D. Ooh, okay, awesome. So I'm getting, I think what I'm getting is the good answer. I haven't done it yet. 8.9, perfect. Let's do it. Now, normally I'd like to give you another minute or so, but I should get going for that test. Again, if anybody has questions, today is not the best, well, right now is not the best time, but after 1:30, I'm free. So you can send me an email or whatever. But let's do the answers for this one. The only way or reason you would get this wrong on an exam is if you didn't kind of label your triangle correctly. D here is what we would call our hypotenuse. And I don't know, that's probably some old Greek word for the longest side of the triangle. So D, my formula, if you're wondering, my formula is going to be D squared equals E squared plus F squared. I'm sorry about my screen. I don't know why it's doing that. It normally only does that when I'm zoomed in, but maybe I need to restart my computer. So D squared equals E squared, so 7.5 squared, plus F squared, 4.8 squared. So D squared. You don't need to show me all these steps either, by the way. Some of you who are very comfortable with Pythagorean theorem, you don't have to show me all these steps. I don't actually ever need you to show me every step. The only problem is if you make a mistake, I don't know where you went wrong, but you don't have to show me everything. Like for example, now all I need to do is take the square root of both sides. So I'm just going to write it like this, the square root of 79. And I get 8.9. It says round it to 1 decimal place. So 8.9 would be the proper answer. For the people who said 9 or 9.0, that's fine. But it does say in the question 1 decimal place in both questions. So there we go. I think you guys might like this unit a little bit better than unit number 3. And well, one reason is because it's tiny. We only have like, I think, a couple more things I need to show you for the final exam. And they're all based on this idea of right triangles. Tomorrow, I have a little bit of information I need to explain about angles. And then we're going to get into the real big stuff, as in cosine, sine, and tangent. I don't know if you guys remember that from high school, but we're going to do a little bit on sine, cosine, and tangent. But that's for tomorrow. So guys, that's it for me today. I have to run to the other test, but I'll have all this stuff uploaded.
Mr. Page 2 and 3 and 4 or 5. We will not take it. Just
Nope.
6.
Nope. All right, any other questions, guys? Other than that, have a good day. I'll be around, I'll be available on email if you need to talk to me for anything, and I'll put your tests outside my door. All right, perfect. Oh, if you're, thank you. If you're wondering where my door is, it's here, 7242A. It'll be outside my door in about 30 minutes. Okay, once I get ready for at work. All right, I'll see you guys later. Have a great day. Woo, one more week. We're almost done. See ya.